So good morning, good afternoon, good evening. Thank you for being here. This is the GeoPose Summit being held hybrid in person in Boulder, Colorado. Thank you to all of our partners who have made this possible. Thank you to the speakers, and thank you to all the participants in person and remote. We love your participation, and we thank you for everything. I'm just facilitating and introducing our next speaker, who needs no introduction, but I'm going to introduce him anyway. Steve Smith, open site plan architect at GeoPose, and he's going to tell you what's coming next. Steve, over to
you. No need for microphone, so we're good.
Understood. Hello. Thank you for being here. So this session talks about how we got to where we are and what we learned after we got here, partly from our own experience. So Rob Smith, who talked this morning, was actually one of the heavy-duty implementers. And so a lot of the ideas and a lot of the feedback comes from him as well as other people. Not all the user feedback was germane, but it was all appreciated and will continue to be appreciated. Because really, as I said this morning, one of the things we're trying to do is to distill the essence of the idea of location and orientation in such a way that we can recognize it in things that exist, and we can do the research. So this is part of the mission, as I see it, is to do the research to understand how we got here in terms of representations and words that we use to describe things, and make some choices about where to go next. So this is probably the last slide with too many words. So when the original idea for GeoPose really came from OpenAR Cloud. At least that's where I saw it coming from. Came into OGC with the intent of standardizing something that had already been written down. We had a long period, maybe 4 to 6 months of discussion of, so what is it we're trying to do? And to a large extent, what we were trying to do was create a standard which made internal sense and which didn't disagree with the already identified use of the GeoPose. And GeoPose already had its name at that point. So we had a lot of discussion about things that could be in a GeoPose, where GeoPose became, in a way, a grand grab bag of kinematic information, identity, other properties, or maybe any property, and looking at what could be accomplished in about a year's actual development time. The group cut it back to what is in GeoPose 1.0, which are 8 different standardization targets. So the basic quaternion that doesn't break no matter which way you point. The basic YPR, which is understandable by humans at a glance. There's some disagreements about directions and order of rotations. And a final piece that influenced the work is the experience with and emergence of visual positioning. Visual positioning as a important use case. And as you'll see, when I work through my, basically you're going to see a replay of my introspection over about a 6 or 8 month period, which led me to some thoughts. And these thoughts are mostly going to be in pictures. And they address some of the things we talked about this morning. And I think they bring up some others. So the first bullet point here is that the idea of pose is actually built into the way humans and lots of mammals and perhaps other animals see. I'm not sure if an octopus eye behaves the same as a horse eye, but I'm pretty sure a horse eye behaves similarly to a human eye. And that is that there's a small patch of retina that's got really good high resolution photoreceptors, and then the rest of it is kind of just a little bit light sensitive. And the process of vision has depended on keeping whatever it is we're interested in sort of statically centered on that really good part of our retinas. And we think in 3D. We definitely understand 3D, but I'll argue that if you think about, again, this is the introspection part, if you think about how you think about space, if you imagine somewhere, like if you imagine the clean room downstairs, you don't imagine that in some neutral three-dimensional sense. You imagine it from a viewpoint. And even worse, you can only imagine things from one viewpoint at a time. Pretty limited. You can switch back and forth between viewpoints. So you can think about the Statue of Liberty and the interior of this room, but not at the same time. You can switch back and forth. So this imagining spaces from a viewpoint is really important. And this affects and relates to, in some sense, just the fundamental two-dimensionality of our sensors and the three-dimensionality or apparent three-dimensionality of the world we find ourselves in. And vision, for the most part, is our portal to mental models of space. So if we think about this, we could take the lessons learned by evolution to think about how we might structure systems for doing machine perception or artificial perception, much the way neural networks have turned out to be a good way to answer questions about integrated information. One of the appeals of visual positioning as something to focus on is that it, in a way, embodies many of the core aspects of this machine perception. So where did all this pose thing come from? So my answer is it came from survival, and survival depends on being able to pay attention to things that are either attractive or dangerous. And we could refer to the thing that we're paying attention to as the subject of our gaze. I think that was George's favorite word from this morning. We could call it focus. It's the thing we're paying attention to. So this really relates to the general subject of visual perception. How do we take what our eyes mostly tell us? So you could repeat almost all of this for other senses. I knew a taxi driver who had a nephew who was blind, and he was trying to teach this blind nephew to navigate a car by the smell of Boston neighborhoods. So, and it's partially worked, but probably not good enough for him to drive a taxi. So I'm not discounting the other senses, but I am focusing on vision. He said the tactic that our eyes are using to make good use of the high resolution part of the retina is to fixate on things, and we're not aware of it, but we're almost always doing one of two things. We're either jumping from one thing to the other, and our brains are telling us that we actually know about everything, but there are famous psychology experiments. There's one where the subjects are instructed to pay close attention to what this group of 3 people are doing, and they'll have to answer questions later. And in the middle of it, a man in a gorilla seat wanders in and wanders through the people, and most of the people never see the man in the gorilla suit. The other thing we do is, if it's something moving, we actually follow, so it's a smooth pursuit. That moving thing, which performs exactly the same function of keeping the image of the moving thing more or less in the same place on the good part of our retina. So, and again, whenever we're doing this, we always feel as though we're aware of the entire space, maybe even what's behind us. So visual perception is really doing 2 things. One of them is it's letting us recognize things to pay attention to. So there are some things that we are really have learned to pay attention to, like the teeth of an attacking lion. There are other things like a bunch of foliage where the details of all the leaves and branches actually aren't important to us. And so it's there, and we can focus on it some little bit and see it in detail, but in our heads, it's just like a bunch of plant stuff. We think we're more aware of things and neutral in our point of view, but we never are. So, for example, this boy is paying attention to a few things, and maybe only these things, and maybe not even all of these things. And there are other things that are in his thinking, but they're very generalized in the same sense as a bunch of foliage. So, like the leaves of grass in the lawn probably aren't individually important. And some of the harmless or not appealing animals aren't paid attention to. And attention is the thing. So this ability to focus or have a gaze or pay attention to things in our environment all come with where we are and where it is. So location and orientation or direction. And this is a pose. Calling it a pose and thinking of it as a concept makes it easy to talk about, easy to exchange information. So this goes for human language as well as exchanging data objects that describe these relationships. So giving a name is really good. One of the complications, and we hit on it several times, and I've come to think of this as being more important than I did a couple of years ago, that there are different kinds, different relationships. So Josh was talking about sort of a graph of relationships, which pose captures. There are a lot of different things going on. Think about the observer who's paying attention to something. That attention or that gaze defines a pose. And you'll see in a minute that I've given some names to these different kinds of poses. I think that one of the deficiencies or difficulties in talking about pose has to do with the words we use to describe these relationships. So my aspiration would be that in follow-on versions, 1 point something, 1.1, 1.2, 1.3, probably around 1.3, that we might start taking account of these differences in poses and giving ourselves a way to characterize what this pose, how this pose should be interpreted, not just as a position and an orientation, but what kind of a pose? Is it my pose, or is it where Amanda is, or is it where Scott is looking, or where Scott is sitting? There are a lot of poses. So, and a lot of this came from Josh's contributions to the beginning of GeoPose. We're really thinking about pose, and so I'll just say GeoPose. I'm going to leave out geo a lot, but the geo part is just connecting this coordinate system that goes with the orientation part to some externally defined coordinate reference system, like WGS84, latitude, longitude, height above the ellipsoid. So when I say pose, I'm not saying GeoPose, I'm just simplifying life. So the idea is that step one is that you make a transformation to the center of visual perception. So that's going to be the center of some local coordinate system. So since you're going from some externally defined thing to like somewhere in my slightly inside my skull, that's a transformation. It's taking 3 coordinates and identifying the origin of my personal coordinate system. So I call it the center of visual perception. And it doesn't actually have to be the center of visual perception for all of this to work, but for this talk, it helps. And then, so that's step one. So you've taken a point in some arbitrary external coordinate system, transformed it to a different frame of reference, which is the frame of reference where this pose is rooted. Second transformation then rotates that coordinate system for some purpose. For example, to point a judge, Christine, or point at anyone who feels they need to be pointed. So transformation to the center, orientation for some purpose. Now, this morning, we actually touched on, or Rob Smith touched on one thing where he said GeoPose, and then I need depth. So this was the LiDAR. I think that having the ability to include a depth with a pose is super helpful and has a lot of practical application, applies to a lot of use cases. So if you think about the orientation, you've defined your rotated coordinate system. You have the axis going out from your face. It's called the y-axis, and it defines a ray. So it's an infinite number of points along a line. So if you pick a point on that line, and if you think about identifying something that you are afraid of or want or have some interest in, that adding this depth information, in other words, selecting a point on that ray, is very natural. So as I note in my slide, sometimes you have that information, sometimes you don't. So like in a human, we have our sort of individual eyeballs able to bring information into our processing system, and we build up a model of our surroundings. But we also have the binocular vision that most people do most of the time. And so we have a form of distance measurement as well.
Others as well, such as things that
Things that paint with distance, or things in front of you include things behind them. So you have some information sometimes. So I wouldn't rule that out as being something for GeoPose. So this boils down to, I think there are three kinds of poses that are pretty well defined. An observer pose. So that's me, wherever my head is, or wherever I'm looking, that's my pose. You obviously could take my center of mass and shoulder line as another way to orient, but it's based on the observer. The second is the direction from the same origin to something I'm paying attention to. I may be staring at Chris. I can vaguely recognize Christine. So I can have that angle and that angle. So this is my angle. That's the subject pose for a thing. Now, in an earlier version of my talking about this, I called them targets. But then people thought, well, what do you do to targets? And so the new name for target is subject. I'm only about 72% happy with these names, so suggestions are welcome. Okay, and then object poses. So I'm looking at Scott, and Scott's facing that way. Scott facing that way is Scott's object pose. So if you think about, someone was talking about orientation of spacecraft, for example. That would be the object pose of the spacecraft, unless I were the spacecraft. So the observer pose is completely based on some kind of a visual sensing system. It has nothing to do with the environment. They do require, so not everything has a pose. So for example, I have a pose because I have a front and back. Many things have a front and back, but some things only have a front and back because you're looking at the front, like a tree or a rock. And those induced orientations aren't going to be shared by anyone else observing the scene. They're personal to the observer. So when I say repeatedly, not everything has a GeoPose. Everything has a position, but not everything has an orientation. And there's like a whole area of behavioral psychology that has to do with this, and it's can get very beyond reason in terms of thinking about that. But all observers have poses, and all things that observers pay attention to have subject poses, but not every object out there has pose. So again, the subject pose, if you think we're sitting in a car looking at the back of a boy looking at a bird, every one of those defines a subject pose. We're looking at the boy, also looking at the lion, maybe, or the cat, and each of those is a subject. Observer poses is exactly the camera thing. So it's totally analogous to the computer graphics pose concept. So some objects, determining their pose requires us to actually recognize that they are what they are. So if we look at a tree and we think it's a car, we might think it has a front bumper. It would be kind of incorrect, but it's our determination, and this applies when you start thinking about using neural networks to do the recognition of what the semantics of the scene are, that you may make mistakes and you may make a difference. And again, things like a tree, they have fronts and backs if you have an observer, but those are private to the observer. So how do you represent a pose? So this gets to be part of the bridge between concepts and a hunk of JSON that describes a pose. Since we've chosen JSON as the representation for now. So there are some additional properties that we haven't considered in the past. So the type of pose, I think is, for some applications, it's important to, when you exchange a pose, to say, well, what kind of a pose is it? So I say Chris's pose, but is that when I orient myself to Chris, or when I look at George and see Chris out of the side of my eye, or is it Chris's own observer pose? One or more depths. So I've worked a bit with the standards group for high-end film production tool data exchange. OpenEXR, and they completely model the thing that you would think of as an image is an image with a depth to different pixels or different sets of color information, which could be at the same row column location in the image, because you may have transparent things or reflections. So it's almost like inverse ray tracing from the point of view of an imaging sensor. So I think that may be overkill for us, but adopting somebody else's standard is always a good idea. Associated uncertainty, so quality, so what's the positional quality of a pose? What's the rotational quality of a pose? Time, part of it to say what time, and identifiers for things. So if you're tracking something and you need at least a temporary identity so that when you see it in the next frame, you can make a judgment whether it's the same thing or not. But when you're an hour later, you may not care. So you may actually need a time limited temporary identity concept. So how do you use poses? We talked a lot about application areas, use cases. So I think surveillance is actually a really, really big one, maybe not a pleasant or harmless one. Being able to interpret in human-like terms huge amounts of surveillance video has a use, maybe misuse. A more targeted version of that is reconnaissance, where you're collecting imagery in order to learn something. Like you might want to pop a drone up and just have it whip around once and come back down, and then understand. You're given a summary of what it's seen, rather than have to look at the video in order to interpret it. Collision avoidance, threat predictions, that's moving things. Rob Smith again talked about that this morning. Crop inspection, autonomous vehicles, environmental inventory monitoring. Tracking in general, which is kind of like surveillance and reconnaissance and navigation molded together as a use case. And one of my favorites actually is avatar substitution. So you're all familiar with, you have an image or a video, and some of the people, or all the people, are pixelated or blurred. Just in the way that you could replace yourself with a cat in Zoom, you should be able to take a video, or you could be able to take a video, and model the person to whatever level of approximation is appropriate. So trying to be precise, but trying not to leak information, and replace that person with an avatar, so that rather than people, you have clearly identified humanoid forms, which are anonymous, but contain the information that your application needs to be there. So there are a lot of thoughts and arguments about, well, what about gait analysis or posture, or a lot of things which actually are pretty personally identifying. How do you filter those out? But in general, if you compare pixelating or blurring to just replacing them with a humanoid form, I think that's, to me, that's a good. So that was sort of like the past, and then a bunch of thinking went on in my head, and a few conclusions I came up with, and a lot of stuff that had to do with, why is pose more than just this computer graphics where the lights or where the cameras thing. And my belief is that it's part of the information that can go through a portal between a two-dimensional visual system and 3D content. Visual positioning does this sort of naturally. You saw this morning that you may well scan an area, build up a point cloud. Then when you get a new image, you find interesting features in an image, try to match them against points in the point cloud. That's how you do the visual positioning. You can also do that using a different representation of the visual capture that you did. Rather than a point cloud, you might use 3D Gaussian spots, or you might use some other radiance field model. Even a radiance field model comes close to the OpenEXR image specification. So, what it really back to, yeah, it actually has a lot to do with people and people's 2D visual systems produce 3D thinking, although people actually can only think about 3D in 2D, which is, they can only think about 3D and 2D, but they can also move themselves around in their heads to different points of view. And so they get an understanding of a 3D environment. So, we talked about these a lot, so I won't say much about them, but we have these 8 different things that we standardize in version 1.0. And the one that makes the most sense for most applications is the basic GeoPose. So a location expressed for the coordinate system origin expressed in WDS84 latitude, longitude, and height above the ellipsoid. And an orientation described by semantics. And there's a lot of discussion about which angles to use, but we picked 3. Or the hard to visualize, but Chris is making a coordinate system with his hand. The hard to visualize quaternion. Although you all know the story of Hamilton back in 1843, he was out on the Sunday walk with his wife, and it all came together in his head. And he was so excited and worried that he'd forget it because it was only like briefly clear. And he carved it into the part of the stone bridge structure in Dublin. And to this day, they have Hamilton walks to recreate that. So, these are the 8 targets that we standardized. And you'll notice some things. So, for example, the basic geoposes don't have time. And the advanced chain and graph geoposes do have time, but people have found those devilishly hard to implement, not the fault of GeoPose, but of the geodesists of the world, each of which, more or less, has decided, I will pick my own model of the Earth and my own zero longitude and my own center of the mass of the Earth. And so there's a lot of choices to make and exactly how that geographic coordinate system is defined. But the net result is that because we just basically gave a container for the coordinate reference system information, and said, go to the other OGC groups and get them to give you a WKT, or go to EPSG and get their code number, or get a proj file and see what the proj string defining your favorite coordinate system is. None of those made anybody even do any work. So what we did was we expanded the scope back up a bit. So one of the things, if you see the parts marked in yellow, uncertainty and camera mode. Uncertainty was left out reluctantly in version 1.0. You might say because there are so many good ways to do it.
They're uncertain about how to do
And uncertain about how to do it. But it's clear that having some measure of quality, which way am I looking when I'm looking at Josh? And where was I standing? I mean, especially for things you do in code, it's important. So this will be maybe too tiny to read, but what it boils down to is we came up with 8 work packages. The first 2 really are just following OGC recommendation to separate conceptual model and encoding. And the third one was based on people saying, oh, we already have sort of our own GeoPose, but if we could use your orientation part, your GeoPose, your quaternion or your YPR angles, then we went. And although we created JSON schema for them and they draw from the UML model, we didn't create requirements for them. We didn't create tests for them. So they're not really standardized. So 1, 2, 3, in a way, it's just sort of editorial. The components brought up the topic of, well, there are other things that could be components. So we'll look at that in a bit, but basically it's just exploding what we did before and making it part of the standard that you test against. We have a group, CRS definition of GeoPose. One of our rules is if there's no activity in a work package, then it'll just silently die. As far as I know, there's not been any work in the CRS definition of GeoPose, which was the problem with the advanced GeoPose version. Time coordinate. We need a time. We picked Unix time for time steps. Several times. Unix time isn't good because it respects leap seconds, the implementation of what that means. Some people have stretched 2 seconds over 1 second worth of counting. Some people just jump, some people jump back and then go forward. A lot of implementation is just wrong, but the point is that if you look at Unix time or POSIX time, that they only agreed at like a dozen seconds. So you can always find probably a worst case in that. So the right answer would have been to use International Atomic Time, because this purely the time coordinate. It's just ticks along an axis, and then the International Earth Rotation Service in France figures out how it relates to clocks around the world. And so if you need to go to like UTC from International Atomic Time, you can do it. It may not be totally straightforward, but you can do it. And we learned that we just needed a time axis that we could depend on to a fraction of a nanosecond. So maybe something like a centimeter, which is about, well, this is a nanosecond.
1 second. Right.
Yeah. So centimeter is a 30th of a nanosecond.
3/5.
Yeah. So that's what we need. And new encodings, perhaps a binary encoding or an encoding for difficult environments with difficult network connectivity. No activity in either one as far as I know. Uncertainty, a lot of activity, so it's quality. And support for visual positioning, this whole number 8, there's a lot of support there.
Want to go back to your slides?
You want to go back to slides?
We can go back. There it is.
That's just.
Okay, so a lot of words about components, but basically I said it all. We had components, we didn't define requirements for them in the standard nor tests. So we're doing that. The core components are position, quaternion, angles, coordinates. So if we look at this in more detail, it's what you see when you look at the standard. So it's not very exciting, but this is the essence of these components. They're little data nuggets. I would say they're more on the side of being data types than classes, but you could think of it as your favorite those two. And the time coordinate we have. So this is
Or is it restarting? Didn't snooze, right? Okay.
no.
Okay, let's.
Time origin. This has a place for a time coordinate reference system. I believe now that we should simply hardwire International Atomic Time into the standard, and the time coordinate dispense with having identification of what our time coordinate reference system is.
We can discuss that.
Yeah.
It may sound like a good idea.
Okay, well, this reflects what I thought in May, but maybe it's still smart. So for uncertainty, one approach, and this is an approach we're actually using in prototyping, is to use two ellipsoids. So one is, if you think about it, you have 3 Cartesian coordinates. And most of the time, total uncertainty is equal at least to those. Let's just say it's unequal between the axes. So we have some distance within which 95% of your measurements of the true location would be within that distance in the x coordinate, another number for y, another number for z. So you end up with a triaxial ellipsoid. And this ellipsoid, or three numbers, becomes your report on the quality of the position. And to do the same thing for orientation, you can think of a sphere, and on the surface of the sphere, you draw an ellipse, which I'm not 100% sure if it's fair to say when you're drawing it on the surface of the sphere, it's still an ellipse, but let's just say that. Which, if you had a vector going from the center of the sphere to the surface, 95% of the pointings would be inside that ellipse. So in most cases, I think it's going to be a circle on the surface. Although if it's a sphere, so a circle on the sphere is going to be a circle. So that tells you how good the pointing is.
Well, certainly an ellipsoid projected onto the surface of the ellipsoid.
So probably go.
You have an elliptical.
Right,
Let's use what you sort of.
thank you.
All agreed an elliptical. Am I talking to it? No? Okay, right.
It's working, right? Yeah.
We've just agreed that the ellipse projected onto the surface of the ellipsoid is not quite an ellipse, but what we're actually talking about is a elliptical cone coming from the center, and the cross section of that at right angles to the axis is an ellipse.
And yeah, so it's actually, for the direction, it's a sphere. So it's the intersection of this elliptical cone and this sphere.
Yeah, there's some uncertainty about that.
Yeah, I mean, there's dependency and systematic uncertainties that make defining it this way, the utility of defining it this way more uncertain, because there's a lot of bias in many of these measurements. But certainly we can get started.
And of course, you should really do it in 4 dimensions, right? So, because you've got the uncertainty in time, but the uncertainty in the spatial dimensions may be dependent on the uncertainty in time.
We should go.
Yeah, at the risk of going down the rabbit hole. So if you're looking at the angular, you see, you get your angular uncertainty on a sphere, but then you're superimposing that over your ellipsoidal spatial uncertainty. So
No, it's a separate. The sphere is not the same as the ellipsoid for the position.
well, if you're gonna turn that into a 4-dimensional uncertainty, that's kind of what you do. But yeah, it all gets murky.
Actually, it's not clean. But it's not clean, but you can understand it.
Yeah.
Fuzzy.
Oh, that's right. I don't need the microphone. I have the microphone. Okay. So the final quality thing is, in visual position, you're reporting back. In visual position, you're reporting back the semantic class of things. This is a person, or this is a poodle. or is some of the work that we did in testbed 19 identifying some people's legs and skateboards? Need to have a measure of confidence in this semantic assignment. No work has been done on that in the group yet.
So, Steve, sorry to interrupt, but Mikhail he has a comment that he shared in the chat about this way of expressing uncertainty as another property. He thinks it would be beneficial to use string values to express uncertainties.
Yeah, not exactly, but yes, the idea is that by using some other kind of representation for the numbers, I believe we can achieve the same thing without duplicating the properties to indicate the uncertainty. Because while I understand why we are doing this, it's like, is there any other way to represent things that are so codependent or interlinked?
Yeah, it's on.
Yeah, I obviously temporarily forget that every so, because Christine is.
Yeah.
pretty much-
So one practical measure would be to have a property which is literally the covariance matrix.
Yeah, I mean, it's
Yeah,
bigger
if
than
it is
one.
something that
Yeah.
applies to multiple properties, I can see it. It's just that for one property, assign a different uncertainty value seems like a little bit overkill.
Say that again.
The idea of having another property associated to another just to express the uncertainty seems a little bit overkill, because then you have to use, for example, latitude uncertainty, longitude uncertainty, height uncertainty, when you can say position uncertainty 3 or 10, or horizontal uncertainty 10, then it makes sense because you have the longitude and latitude. It's not the same thing, you know.
But you know what? This is something we'll need to discuss in this week. But say the example of the latitude, longitude, and height reported to you by GPS in your phone, for example. The height uncertainty is huge compared to the horizontal position uncertainty. So if you're going to capture that, also if you're going to capture systematic errors in that, which are important, that's part of the issue, where if you just have one number, it seems to me like it doesn't do a good job of conveying the message that, okay, this location is good to a meter, but the height's good to 8 meters or something.
Okay.
That's what I'm thinking. I'm just thinking.
Yeah, it's just that for me, I understand that properties like, say, angle, if we use a string representation similar to well-known text, for example, but to represent this kind of things, is like if you have a float or a double for the value, it's just that value. But if you have a string, you can have uncertainty, you can have all kinds of things. You can even have additional units. For example, 1 radian, for example. So how will it make sense to include the things like uncertainty as part of the value instead of generating another property?
Can I just comment on
Partly
that?
because I think that in many cases, you can characterize the uncertainty once for a large number of values. And so separating them let you factor that out, so you don't have to repeat it every time.
I was just going to say, some of the work we're doing in the API working groups and in the coverage adjacent working group is identified that where we have a parameter, a variable, an observed measurement or whatever, the coverage adjacent standard allows you to have a parameter group, an object, rather than just a value, not just a string
Okay.
or a number.
Yeah, no, that
And
would be
that's
better.
we're having a bit of a debate is what is a parameter group, and there's about 4 use cases,
Bag
but one
of
is
stuff.
the value plus its associated quality or
Mhm.
statistics. And by having it as an object, you can treat it as one thing, and that may be the way to do it.
Yeah, I can see that.
Yeah, so this is a formatting argument, but we haven't settled any of the fundamental questions of what uncertainties are important here. You know, if you're doing individual uncertainties, you can't express any of the covariances. You can't express any of the systematic uncertainties from observation. So let's find out the fundamental needs first and then figure out how to format them.
Yes, although I personally am putting the cart somewhat before the horse by saying, in order to do the VPS benchmarking, we actually need to know an answer. So I'm presuming an answer, and then it's not the standard, it's the prototype, and we can discuss it and do the right thing. Yeah. But that's
Not for
that's a
individual
good approach.
parameters because it involves all the parameters.
Well, it's a thing that can characterize a bunch of other things collectively, which achieves the compactness and the specificity, opposing goals that we. Okay, so I'm not going to say too much about the detailed BPS support because
We started 5 minutes late, we're now at 1 hour for this session.
that's what I was going to really simply say that there are additions that have to do with visual positioning support. And if you are particularly interested in visual positioning, so I had a presentation this morning that actually had the basics where image goes in, GeoPose comes back, other stuff could go in, and other stuff could come back, but that's the essence of it. And the VPS support has to do specifically with some of those other things that could come back. So if you're interested, email me or take a look at the slides. But I think it's 2 days out from now.
It's about to restart.
Is it seen again? Oh. 4 minutes, 14.
Top, excellent job. This is a comment I'd like to make, Steve, which is, I think, a generalization of some of the things that you've been talking about. So, you know, we talked around and got a basic structure, which should be the conceptual model for GeoPose of frame transformation. And we had sort of said, well, the information we need is, you know, frame, transformation, frame. There's a basic. Unfortunately, we oversimplified, and that's leading to some of these problems of different kinds of gazes. We really meant by a basic GeoPose was we have a frame of the Earth. We have a transformation into an ENU frame. Then we have a transformation into a local frame. And then we have another transformation into a frame which is defined by the object that is being posed, or some attribute of that, such as the gaze, such as the positioning of wings, so that we've left one, we've sort of assumed the Earth for the GeoPose, which makes it hard when we're not using the Earth. And we've kind of assumed that the application figures out how that inner frame actually transforms into the object. So I think if in the course of this work, we gradually make some of these more formal and explicit, even if they don't need to be included as information in particular forms of pose and GeoPose, that it would help with some of these ambiguities that I think we're wrestling with.
Yeah, there's a lot of misinformation. Well, there's a lot of good information. There's a lot of misinformation. If you go to the Wikipedia articles describing Euler angles or quaternions or related things that have to do with rotation, there's a lot of contradiction and a lot of mistakes. There are a number of things which are stated, which I believe are the exact opposite of how they should be. And a lot of it has to do with the order that rotations are applied and whether they're applied to an original non-changing coordinate system or the coordinate system after the previous rotation, and a few other things which create this split between Euler angles and Tate-Bryan angles.
But those are, in some way, those are issues of the transformations. And if we do a more explicit job of defining the frames that we're working with, then we can reconcile some of those inconsistencies maybe a little bit better.
Yeah. I think we should try to have a clear, simple, correct story for each of the things.
Yeah.
That's one of our concepts. It would be a contribution to all the other uses.
Yeah.
I believe.
I mean, selfishly, I need this for the GeoPose ontology, because we need specific concepts and relations for that. And I went through the standard a lot and I didn't find them. So we should come up with them.